Okay, I'm going to go over a couple examples of how to solve exponential equations where um, you're trying to solve for the variable x. So I'll show you one way, which is where you quote unquote log both sides and then use the power rule to undo the exponent. The second one will use the definition of log, or rewriting an exponential in log form, and then using what's called a change of base formula. So let's say I have 3 to the x equals 15. The first thing I want to do is I want to isolate the exponential. The exponential is going to be some number to the x power, something like that. So we have 3 to the x equals 15. So the exponential is already isolated. Now what we'll do is we'll use the log and the power rule to solve for the exponent. You either want to use log, log, base 10, or it'll just appear to be log on your calculator, or you want to use the natural log ln, and that's log base e, because those are the two that your calculator and most calculators will use. So this would, if we log both sides, so it's a function, so kind of like squaring both sides or adding 5 to both sides, we can log both sides. Then we're going to use the power rule to take the exponent of x, and we're going to bring it down. And all log of 3 is now is it's just a number. That's something you can plug in your calculator and you can find what that is. But it would be better to leave it as log 3, because if you write it as a number, it's going to be a big messy decimal, and then you're introducing rounding error. So we'll divide both sides by log 3, and we'll have log 15 over log 3. And I can't combine those. I don't have a rule that says I can combine them this way. The quotient rule is a one log with a quotient inside. This is 2 logs, and the quotient's not inside both of them. The quotient's not contained in a single log. So if I don't have one log with a quotient, then I can't use it. So this is a quotient with 2 logs. Okay, so if I plug that in my calculator, the exact answer is log 15 over log 3. In your calculator, you're going to get an approximation, and it's probably good to take it to about 4 decimal places. That's probably what my math lab's going to ask you. I might ask that on the test or something like that, but 4 decimal places is usually safe. Okay, let's do 0.88 to the x power equals 15. Again, the 0.88 to the x, that's the exponential. It's already isolated, so I don't have to do anything. And at this point in time, I can either log both sides or I can ln both sides. Doesn't matter. Your calculator has both buttons, and you'll get the same answer no matter whether you use log or ln. I like writing ln just because it's one less letter to write, but it's up to you. So ln of 0.88 to the x equals ln 15. Now it doesn't matter. If you're wondering, if I write the x in the inside or on the outside, you see that I have that there. Doesn't matter, the notation is understood both ways. Alright, we're going to use the power rule to bring this exponent down. So ln of 0.88 is just a number, ln of 15 is just a number. Okay, and then we're going to divide by ln of 0.88. And then we'll put that in our calculator and get x is approximately negative 21.1842. Okay. If you have any calculator trouble, send me an email or talk to me in class. A lot of times it's parentheses issues. Be careful with your parentheses. Okay. Let's do one more. 3 times 5 to the x power equals 21. The exponential is 5 to the x, and 5 to the x is not isolated. It has a neighbor there, the 3. So we need to get rid of the 3, and the 3 is attached by multiplication. So what we want to do is we want to divide both sides by 3. 5 to the x is equal to 7. And now we can log both sides or ln both sides. I'm going to go ahead and ln both sides. And then we'll use the power rule to bring this x down. ln of 5 is just a number, so we can go ahead and divide by it. X is equal to ln of 7 over ln of 5. That's the exact answer. And the approximation, 1.2091. Okay. I'm going to show you another way of doing this using the change of base formula and also the definition of log. By what I mean is rewriting a log in its, or rewriting an exponential in its log form. So change of base formula. I think in your book they show you a little derivation of it. So if I have log base b of x, I can rewrite it in terms of any base that I want, but the bases that we're interested in are what your calculator can do, which is log base 10, and that's just the log button on your calculator, or natural log, which is the ln button on your calculator. So it's going to be log of the argument divided by log of the base. Or if you want to do natural log, it's natural log of the argument divided by the natural log of the base. And we can do those three problems that we just did, but we can do them using rewriting into a log form and then using change of base. So 3 to the x equals 15. So the base is 3. Argument is 15 equals your exponent of x. Okay, most calculators, not all, but most calculators don't have log base 3 programmed into them. So you have to use the change of base. So it'll change into log of the argument divided by log of the base. So it'll be log of the argument, 15, divided by log of the base. And that was exactly what we got last time. Now you just need to put it in your calculator. Okay. If I look at b, 0.88 to the x equals 15. Again, I didn't mention this, but in order to use the definition of log or to rewrite an exponential, this is an exponential in log form. It needs to have the exponential part isolated. Okay, so this is going to be log of 0.88. Argument is 15, and that's going to equal your exponent of x. Change of base, log of argument over log of base equals x. And then all you got to do is plug that into your calculator and see. 3 to the 5x, or I'm sorry, 3 times 5 to the x power equals 21. Again, we need to isolate the logs. We'll divide both sides by 3. And I see I made a boo-boo. Let's change this. This should be a 7. Okay. Oh, geez. Having trouble writing. All right. So this be log base 5 of not 21. Argument is 7 equals exponent of x. And then using change of base, not 21, sorry, it was 7. I made a boo-boo. Alright, so this time I'm using change of base with natural log. It doesn't matter if you use natural log or log, because your calculator does both of them and you'll get the same answer. So ln of 7 is the argument, and then ln of 5, that's for the base. That's going to equal x, and then you can plug that into your calculator, and you'll get the same answer. So some students like to log both sides, and then some like to rewrite using the definition of log. So if you want extra practice with the definition of log, going back and forth from exponential to log form, maybe the second approach is a little bit better, and then you just need to know the change of base formula. And some folks like taking the log both sides, so it's kind of a matter of preference.